Welcome to the first section of our Oracle GoldenGate 23ai certification journey, where we will uncover the core architecture and the modern microservices framework. In this lesson, you will learn exactly how GoldenGate moves data in real time across different systems, which is the foundational knowledge required for both the exam and your daily job. Understanding this architecture is incredibly important because it dictates how you will install, manage, and troubleshoot your entire data integration environment. Get ready to explore the specific components that make this technology so powerful, as we build your confidence for the certification exam. Let us dive right in and start mastering the building blocks of Oracle GoldenGate. Before we look at the individual moving parts, it is essential to understand what Oracle GoldenGate actually does at a high level. GoldenGate is a software product that captures database changes in real time, routes them across a network, and applies them to a target database. This means if a customer updates their address on your website, GoldenGate immediately detects that specific change and copies it to your backup or analytical systems. It does this without slowing down your primary database, which is a major reason why large companies rely on it. On the exam, you will be tested on how this continuous, low-impact replication is achieved. The secret to this low-impact replication lies in how GoldenGate reads data. Instead of constantly asking the database for updates, which requires heavy processing power, GoldenGate quietly reads the database transaction logs. Transaction logs are files where the database automatically records every change before making it permanent. By reading these files directly, GoldenGate operates outside the normal database workload, making it incredibly fast and efficient. This process of reading from the logs is called log-based change data capture, a critical term you must remember for the certification exam. In previous versions, GoldenGate used a classic architecture with traditional background processes. But version 23i fully embraces a microservices architecture. A microservice is simply a small, independent software application that performs one specific job very well, instead of having one massive program that does everything. GoldenGate 23i breaks its operations down into smaller, web-based services. This modern approach makes the software much easier to manage, secure, and deploy in cloud environments. The exam heavily focuses on this microservices architecture, so we will spend time exploring each specific service. The central hub of this new architecture is called the Service Manager. You can think of the Service Manager as the master control room for your entire GoldenGate environment. It operates as a watchdog, ensuring that all the other microservices are running smoothly on your server. If one of the smaller services accidentally stops, the Service Manager can automatically restart it to keep your data flowing without human intervention. Understanding the role of the Service Manager is absolutely necessary for passing the certification, as it is the first thing you interact with during setup. Once the Service Manager is running, you will primarily interact with the administration server. The administration server is the main user interface where you will spend most of your time configuring your replication tasks. It provides a beautiful web-based dashboard where you can create, edit, and monitor your data extraction and delivery processes. You no longer need to rely solely on complex command line screens to manage your environment. though command line options still exist for advanced users. The exam will definitely test your knowledge of what administrative tasks are performed inside the administration server. The next crucial microservice to understand is the receiver server. As the name suggests, the receiver server has one very specific job, which is to receive data coming in from another GoldenGate system. Imagine you are sending data from a database in New York to a database in London over the Internet. The receiver server in London acts as the secure front door, accepting the incoming data and safely storing it on the hard drive. It ensures that the incoming data is exactly what was sent, maintaining perfect data integrity across the network. Working hand in hand with the receiver server is the distribution server. While the receiver server acts as the front door taking data in, the distribution server acts as the shipping department sending data out. When data changes are captured from your source database, the distribution server packages those changes and sends them across the network to the target system. It is highly intelligent and can send data to multiple different locations at the exact same time. The exam frequently asks about the relationship between the distribution server and the receiver server. So remember that they work together as a pair over the network. Now let us look at the actual data files that these servers move around, which are called trail files. A trail file is simply a temporary storage file on your server where GoldenGate keeps a secure record of the database changes. When data is captured, it is written into a trail file. And when data is sent across the network, it is read out of a trail file. These files act as a safety net, ensuring that if the network goes down, your data is never lost because it is safely waiting on the hard drive. You must know what a trail file is, as it is the absolute backbone of GoldenGate data movement. To manage all this data movement over time, GoldenGate 23ai uses the performance metrics server. This service acts as your personal monitoring system, constantly collecting statistics about how fast data is moving and if any errors are occurring. It provides real-time graphs and charts, allowing you to instantly see if your replication is slowing down or facing a bottleneck. In a real-world job, you will check the performance metrics server daily to ensure your environment is healthy. The certification exam expects you to know exactly which service provides these critical health and performance statistics. All of these microservices communicate with each other using a standard technology called REST application programming interfaces, commonly known as REST APIs. A REST API is essentially a universal language that allows different software programs to talk to each other over a network. Because GoldenGate 23ai uses REST APIs, you can write simple scripts to automate your daily tasks without ever clicking through the dashboard. This means you can easily integrate GoldenGate with other modern enterprise tools your company might use. Expect exam questions testing your knowledge of REST APIs being the primary communication method in the microservices architecture. Let us zoom in on the actual programs doing the heavy lifting. Starting with the extract process. The extract process is the specific engine that actually connects to your source database and reads those transaction logs we discussed earlier. It is responsible for grabbing only the data changes you care about, like customer updates, while ignoring irrelevant changes, like temporary system files. Once it captures the data, The extract process writes it into a local trail file on the same server. You will configure the extract process inside the administration server. And mastering its behavior is a huge part of your exam preparation. On the opposite side of the pipeline, we have the Replicat process. If extract is responsible for capturing the data, Replicat is responsible for delivering the data into the target database. The Replicat reads the incoming trail files, translates the GoldenGate data format into standard database commands, and applies them to the target system. It ensures that the exact same transactions that happened on the source system happen in the exact same order on the target system. Understanding the Replicat process is critical because this is where data finally becomes visible and usable to your end users. Between the extract and the Replicat, you might sometimes use an optional process called the data pump. The data pump is a secondary extract process that does not connect to the database, but instead simply reads local trail files and pushes them across the network. While the modern distribution server handles most network routing today, the data pump is a classic component that is still widely used in older architectures and is heavily tested. It adds an extra layer of protection against network failures, which is why many enterprise architects still choose to implement it. Security is built directly into the microservices architecture from the ground up, not just added as an afterthought. Every single microservice uses advanced encryption by default, meaning all data moving between your servers is scrambled and unreadable to network intruders. Furthermore, to log into any of the web dashboards, you must be authenticated and authorized, ensuring only approved administrators can make changes. This secure by default design is a major selling point for Oracle GoldenGate 23ai in banking and government sectors. The certification exam will require you to deeply understand these built-in security principles. Another important concept for the exam is the concept of a deployment. In GoldenGate 23ai, a deployment is a specific grouping of microservices designed to handle a particular replication task. For example, you might create one deployment for your human resources database, and a completely separate deployment for your sales database, all running on the same physical server. This keeps different business units isolated from each other, so an error in the sales system does not bring down the human resources system. Creating and managing deployments is a fundamental administrative task you will perform frequently on the job. To manage your deployments from a command prompt, Oracle provides a powerful tool called the admin client. The admin client completely replaces the older command line interface from previous versions, which was known as GGSCI. You can type commands into the admin client to start processes, view error logs, and configure security, making it a favorite tool for fast typing administrators. Even though the web dashboards are excellent, the exam will test your ability to use the admin client because it is essential for enterprise automation. You must be comfortable knowing when to use the web interface versus the command line. One of the most exciting additions to the 23i release is the native support for artificial intelligence and vector databases. Vector databases are specialized systems that store complex AI data, and GoldenGate 23i can now replicate this highly complex data just as easily as standard text. This means companies can now keep their global artificial intelligence models synchronized in real time across different continents. While we will dive deeper into this later, you need to know right now that AI vector support is a defining feature of the 23i release. The exam blueprint specifically mentions this new capability, so you must keep it in mind as we wrap up these architectural concepts. It is important to visualize the entire flow from start to finish. A change happens in the source database. The extract process reads the log and writes a local trail file, and the distribution server sends it across the network. The receiver server accepts it into a remote trail file. And finally, the Replicat process applies it to the target database, all monitored closely by the performance metrics server. If you can memorize this exact sequence of events, you will be in a fantastic position for both real-world troubleshooting and the certification test. Congratulations on completing the first section of our Oracle GoldenGate 23i course. I highly encourage you to complete the attached practice test right now while these architectural concepts are fresh in your mind. Practice questions dramatically improve your memory retention and will expose you to the specific way Oracle words their exam questions. Taking the practice test included with this lesson is an active learning step that separates successful candidates from those who struggle on exam day. Stay positive. Keep up the great momentum. And I will naturally transition you into our next section where we will tackle installation and environment setup. Welcome back to the second section of our comprehensive preparation course, where we shift from theoretical architecture to hands-on installation, configuration, and environment setup. In this lesson, you will master the exact steps required to successfully install Oracle GoldenGate 23i and prepare both your source and target databases for real-time replication. Setting up your environment correctly is a major milestone because a shaky foundation will lead to configuration errors later on. Which is why the certification exam places a massive emphasis on these exact procedures. Get excited because today you transition from learning how things work to actually building them, which is where real engineering skills are born. Let us prepare our systems and dive straight into the practical steps of setting up our environment. Before you can run any installer, you must understand the core operating system prerequisites that Oracle GoldenGate 23i expects to find on your server. Whether you are deploying on Oracle Linux, Red Hat Enterprise Linux, or Windows Server, GoldenGate requires a minimum amount of random access memory and adequate hard drive space to store its software binaries and future trail files. You also need to ensure that the operating system has the correct kernel parameters and system libraries installed, particularly those required for networking and database client connectivity. Skipping these system checks is one of the most common mistakes candidates make in real jobs, leading to silent failures during the software setup. When organizing your GoldenGate installation, you need to understand the distinction between the software home directory and the deployment home directory. The software home directory, which administrators refer to as the OG_home, is where the actual unchangeable execution files and system libraries reside after installation. On the other hand, the deployment directory is where all your custom configuration parameters, local trail files, and individual microservices data will live. Keeping these directories separate allows you to upgrade your core GoldenGate software in the future without accidentally modifying or deleting your critical replication rules and data. To actually install the core software binaries, You will use the Oracle Universal Installer, which can be run in either a graphical interface mode or a silent text-based mode. In large corporate environments, administrators heavily favor the silent installation mode because it allows them to automate installations across hundreds of servers using a simple text file called a response file. A response file contains pre-written answers to all the installer questions, such as the exact file paths for your software home and the type of database you intend to replicate. The certification exam expects you to know that a response file is the key to achieving automated, consistent, and headless software installations. A major design pattern tested heavily on the exam is the GoldenGate hub deployment model, which is the recommended approach for modern enterprise environments. In a traditional setup, you would install GoldenGate directly on the same physical server where your database is running, which consumes valuable database processing power. In a hub deployment model, you install GoldenGate on a completely separate, dedicated server, which then connects to your databases remotely across the network. This keeps your production database completely clean and isolated from the processing overhead of data replication, which database administrators absolutely love. To make this hub deployment model work, GoldenGate utilizes specialized methods known as remote capture and remote delivery. Remote capture means the extract process runs on your hub server, but reaches across the network using standard database client connections to read the logs of your source database. Similarly, remote delivery means the Replicat process runs on the hub server, but sends database commands across the network to apply updates to the target system. Understanding how remote capture and remote delivery communicate across a network is highly relevant for the exam, as it forms the basis of modern cloud-based data replication. Now that the software is in place, you must prepare the underlying source database, which requires making specific configuration changes so GoldenGate can read its changes. First and foremost, an Oracle source database must be placed into a special mode called archive log mode, which ensures that older transaction logs are saved to disk rather than overwritten. If the database overwrites its older logs before GoldenGate has a chance to read them, your replication pipeline will break and data will be lost. Ensuring archive log mode is active is the very first database prerequisite you must verify before starting any data capture. In addition to saving your logs, you must also enable a setting called supplemental logging inside your source database. By default, a database only writes the bare minimum amount of information to its transaction logs to save space, which is often not enough for GoldenGate to identify unique rows. Supplemental logging forces the database to write extra identifying details into the logs, such as the primary key columns, every time a row is modified. Without this extra information, the target database will not know exactly which row it needs to update, leading to replication errors. You will definitely see exam questions regarding why minimal supplemental logging must be enabled at the database level. Once the database logging options are correctly enabled, you must create a dedicated database user account that GoldenGate will use to log into the system. This user account requires highly specific administrative privileges so it can read transaction logs, lock tables during setup, and execute data manipulation commands, instead of granting generic administrative roles. You should use a built-in database package called dbms_GoldenGate_auth to securely grant the precise privileges required. Utilizing this specific database package ensures that your security meets enterprise compliance standards, making it a favorite topic for certification question writers. To allow your newly installed GoldenGate processes to communicate with your databases, you must configure network connectivity files, specifically the TNS namesora file. This configuration file acts like a phonebook for your network, mapping simple database alias names to complex network Internet Protocol addresses and port numbers. Every time an extract or Replicat process wants to talk to a database, it looks up the alias in this file to find the correct path across the network. Alternatively, you can use modern EZ-Connect strings, which embed the connection details directly into your configuration parameters, skipping the file lookup entirely. Security is a massive part of the environment setup, and you must never store plain text database passwords in your GoldenGate configuration files. To solve this security challenge, GoldenGate provides a feature called the Credential Store, which is a secure, encrypted digital vault on your server file system. Instead of typing a raw password into a clear text parameter file, you store the password inside this secure vault and assign it a simple nickname known as an alias. The exam will expect you to know that using the credential store is the mandatory best practice for protecting database access credentials. To add credentials to this digital vault, you will use the admin client tool and execute a specific set of commands to initialize and populate the store. First, you create the store using the add credential store command, and then you add your specific user IDs and passwords using the alter credential store command. Once these entries are safely locked inside the vault, your GoldenGate processes will reference the user by their alias name rather than their real password. This mechanism ensures that even if an unauthorized person looks at your configuration files, they will never see sensitive database passwords. With the database and credentials prepared, it is finally time to configure your GoldenGate microservices by launching the Configuration Assistant tool. The Configuration Assistant is a guided utility that helps you set up your very first service manager, which we learned is the master control room. During this wizard process, you will specify the exact network port number that the service manager will listen on to accept incoming connections. Choosing a clear and organized port numbering strategy is vital, as every single microservice you create will require its own unique network port to communicate. After your service manager is operational, you will use it to create your very first deployment, which houses the individual servers for administrative and routing tasks. When creating a deployment, the wizard will automatically generate the administration server, the distribution server, the receiver server, and the performance metrics server. Each of these services will be assigned their own distinct ports, and they will register themselves automatically with the service manager. On the exam, remember that a single service manager can manage multiple deployments, allowing you to run separate environments on a single physical host. During this deployment creation phase, you must decide whether to configure your environment as a secure deployment or an unsecure deployment. A secure deployment uses secure sockets layer certificates to encrypt all web traffic and communication between the microservices, which is essential for production environments. if you select a secure deployment. The wizard will prompt you to provide valid digital certificates or allow GoldenGate to generate temporary self-signed certificates. Understanding how secure deployments utilize encryption keys to lock down network traffic is a core security competency tested on the certification exam. Before starting your new deployment, you must double-check that your operating system environment variables are correctly configured in your user profile. The most critical variable to set is the ld_library_path, which tells the operating system exactly where to look for database client libraries on the hard drive. If this variable is missing or points to the wrong directory, your GoldenGate processes will crash immediately upon startup because they cannot find the code needed to talk to the database. Ensuring this environment variable is set correctly for the GoldenGate operating system user is a vital step in your post-installation checklist. A common mistake that many candidates make during their initial setup is failing to check file system permissions for the GoldenGate operating system user. The user account that runs the GoldenGate software must have full read and write permissions to both the software home directory and the deployment directories. If the permissions are restricted, the microservices will fail to write critical trail files or update internal status logs, causing mysterious errors that can be hard to diagnose. Always ensure that your operating system user belongs to the correct user groups, such as the database administrator group, to prevent these permission roadblocks. Once everything is configured, you can verify that your microservices are running at the operating system level by checking the active system processes. On a Linux server, you can use standard terminal commands to look for a process named Service Manager, which indicates that the main control room is active. If the Service Manager process is visible, it means your configuration assistant successfully completed its work and the core framework is up. From this point forward, you can transition away from the black text-based operating system terminal and move into your clean web-based graphical dashboards. To perform your final verification, you will open a web browser. Type in the Internet Protocol address and port number of your Service Manager, and log into the web console. Inside this dashboard, you should see all your microservices marked with a green status indicator, showing that they are healthy and ready for work. You can also connect to the environment using the admin client from your command prompt by typing the connect command followed by the secure URL of your deployment. Successfully logging into both the web interface and the command line client confirms that your installation and environment setup are completely flawless. Congratulations on successfully finishing the second section of our course and mastering the intricacies of installation and environment setup. I highly encourage you to tackle the attached practice test right now to lock in these critical configuration steps while they're completely fresh in your mind. Answering practice questions is an outstanding active learning habit that reinforces your technical understanding and prepares you for the specific troubleshooting scenarios you will see on the actual exam. Taking the practice test included with this lesson will boost your confidence and ensure you are perfectly ready as we naturally transition into our next section, where we will configure our very first extract, Replicat, and initial load processes. Welcome to the third section of our Oracle GoldenGate 23ai masterclass, where we bring your replication environment to life by configuring the initial load, extract, and Replicat processes. In this lesson, You will learn how to safely copy all your existing database records to a new system and then seamlessly switch to real-time synchronization. This topic is absolutely vital because transferring millions of existing records without losing a single incoming transaction is the most critical phase of any database migration. Get ready to uncover the exact sequence of steps required to start moving actual data, as this knowledge will form the core of your daily administrative duties. Let us dive right in and transform your empty target database into a perfectly synchronized replica. Before you can start capturing real-time changes, you must ensure that your source and target databases contain the exact same starting data. This foundational step is called the initial load, and it involves taking a massive snapshot of your current database and physically copying it to the target system. If you skip the initial load and simply start replicating new changes, your target database will be missing years of historical data and will instantly produce errors when users try to update records that do not exist. Understanding the purpose of the initial load is a fundamental requirement for the exam and your career. Performing an initial load is very different from standard real-time replication because it deals with massive volumes of static data rather than a continuous stream of tiny updates. While the extract process reads transaction logs for real-time changes, an initial load process queries the actual database tables directly to grab everything at once. Because querying massive tables takes a significant amount of time, the initial load must be carefully planned so it does not overwhelm your production database during peak business hours. The certification exam will test your ability to differentiate between continuous change data capture and these heavy initial load operations. There are several methods to perform an initial load, but the most common approach is using specialized Oracle tools like data pump export and import. You simply export the tables from your source database into a large file. Move that file across the network and import it into your target database. Alternatively, you can use GoldenGate itself to perform a direct initial load by creating a special extract process that pulls table data and sends it directly to a special Replicat process. While the GoldenGate direct load method is useful for heterogeneous environments involving different database brands, using native database tools is generally much faster and preferred for Oracle to Oracle migrations. The biggest challenge during any initial load is that your production database does not stop working while you are copying the data. Customers are still placing orders, meaning the data is constantly changing while your massive copy operation is running, which could lead to missing transactions. To solve this, GoldenGate tracks a special marker called a commit sequence number, or CSN, which acts like a highly precise timestamp for every transaction. By recording the exact CSN when your initial load begins, GoldenGate knows exactly which real-time changes happened during the copy process and can apply them later so nothing is lost. Once your initial load is safely underway, you must configure the primary extract process to begin capturing those ongoing real-time changes. The extract process is the true workhorse of GoldenGate, sitting quietly on your hub server and continuously reading the source database transaction logs. You configure this process by creating a simple text file known as a parameter file, where you write out the exact instructions and rules for data capture. Writing and understanding extract parameter files is a major portion of the certification exam, so you must become comfortable with their specific syntax and structure. Inside the extract parameter file, The most important instruction is the table statement, which tells the process exactly which database tables it needs to monitor. Instead of writing a separate statement for every single table, you can use an asterisk as a wildcard character to select hundreds of tables at once. For example, typing table hour ** tells the extract to immediately capture changes for every single table located inside the human resources schema. Using wildcards correctly is a huge time saver for administrators and a frequent topic on the exam when discussing efficient parameter file design. In modern Oracle environments, you will configure your extract process to run in integrated mode rather than the older classic mode. Integrated extract works directly with the internal database engine by utilizing a built-in feature called the log miner server. Instead of GoldenGate manually digging through the transaction logs itself, the log miner server does the heavy lifting internally and hands the perfectly formatted changes directly to the extract process. The exam highly favors integrated extract because it fully supports modern database features like transparent data encryption and compressed tables, which older methods struggle to process. After the extract process captures the data, it packages it into universal GoldenGate formats and writes it to a local trail file. It is important to realize that the extract process does not care what type of target database you are using. Its only job is to translate source data into this universal trail file format. This decoupling is what makes GoldenGate so flexible, allowing a single extract process to supply data to an Oracle database, a Microsoft SQL server, and a cloud data warehouse simultaneously. You should expect exam questions focused on how the extract process isolates the source database from the complexity of network delivery. Now let us move across the network to the delivery side and examine the Replicat process, which is responsible for applying the captured changes. The Replicat process constantly reads the remote trail files waiting on your target server and translates the universal GoldenGate data back into native database commands. Just like the extract, the Replicat is controlled by its own parameter file where you define the specific rules for data delivery. The main difference is that while the extract uses a table statement to select data, the Replicat uses a map statement to decide exactly where the data should go. The map statement is incredibly powerful because it allows you to change the destination of your data on the fly. For instance, if a table is named employees on your source database, but is named staff on your target database, you use the map statement to link them together. The parameter would read map_hour.employees, target_hour.staff, seamlessly bridging the gap between two completely different database designs. Understanding the syntax of the map statement is absolutely essential because it forms the basis of all data transformation, which we will explore deeper in the next section. When configuring your Replicat process, you must choose an operating mode, and the traditional choice is non-integrated Replicat, often called classic Replicat. In this mode, the Replicat acts exactly like a standard database user, constructing standard SQL insert, update, and delete statements and executing them one by one. While this mode is highly reliable and works with almost any database brand on the market, it can sometimes struggle to keep up with extremely busy systems because it processes transactions serially. The exam will expect you to know that classic Replicat is the universal fallback option for heterogeneous database environments. For pure Oracle to Oracle replication, you should upgrade your delivery process to use integrated Replicat mode, similar to integrated extract. Integrated Replicat leverages a native database component called the inbound server to apply changes much faster than standard SQL statements. The inbound server is highly intelligent and automatically understands the hidden relationships between your tables, allowing it to apply independent transactions at the exact same time without causing data locking issues. You must understand that integrated Replicat provides a massive performance boost specifically for Oracle target databases. If you require absolute maximum performance, especially in modern cloud environments, you will utilize the advanced parallel Replicat mode. Parallel Replicat breaks the incoming data stream into numerous smaller streams and uses multiple background threads to apply them simultaneously. It maps out the dependencies between different transactions in a fraction of a second, ensuring that high-speed parallel processing never breaks your data integrity rules. The 23i certification places a heavy emphasis on parallel Replicat because it is the ultimate solution for handling massive enterprise workloads and preventing replication bottlenecks. An alternative multi-threaded option you might encounter is coordinated Replicat. In a coordinated Replicat setup, GoldenGate actually launches multiple individual Replicat programs that work together as a team, splitting the workload based on specific tables. While parallel Replicat is generally superior because it manages the workload automatically, coordinated Replicat is still useful for specific legacy environments where you need strict manual control over which threads process which tables. The exam will likely ask you to compare parallel Replicat with coordinated Replicat. So remember that parallel is automatic and highly modern, while coordinated is manual and specialized. A critical safety feature built into both the extract and Replicat processes is the concept of a checkpoint. A checkpoint is simply a saved bookmark that records exactly which transaction the process just finished handling. If your server suddenly loses power and restarts, the extract and Replicat processes will look at their checkpoints, find their bookmarks, and resume processing exactly where they left off without duplicating or losing any data. Checkpoints guarantee absolute data safety, and you will definitely see exam questions regarding how checkpoints are stored on the file system and inside the database. To track the performance of your running extract and Replicat processes, you will continuously monitor a metric known as lag. Lag is the measure of time between when a transaction occurs on the source database and when it is finally applied to the target database. In a perfectly healthy GoldenGate environment, the lag should be measured in mere milliseconds, meaning the target database is almost perfectly synchronized with the source. If your lag suddenly jumps to several minutes or hours, it is an immediate warning sign that a process is stuck or your network is severely congested. Starting your processes in the correct order is a mandatory procedure for ensuring a smooth initial synchronization. First, you start your primary extract process to begin capturing changes, even though the target database is not ready yet. Next, you perform your heavy initial load using a tool like data pump, letting the extract safely buffer all the ongoing changes into local trail files. Finally, once the initial load is completely finished, you start your Replicat process and tell it to apply the buffered trail files based on that specific CSN timestamp we discussed earlier. This precise orchestration of the initial load and real-time capture allows you to migrate massive databases with zero downtime for your end users. It requires careful planning, a solid understanding of parameter files, and a firm grasp of how Extract and Replicat interact with the database engine. By mastering the sequence of capturing the CSN, starting the extract, running the data export, and launching the Replicat, you elevate yourself from a basic user to a professional replication engineer. The exam tests heavily on this sequence because doing it out of order will completely ruin a production migration. Congratulations on completing the third section and mastering the critical steps of the initial load, extract, and Replicat processes. I highly encourage you to complete the attached practice test right now to reinforce how these components work together in a real migration scenario. Practice questions dramatically improve your retention and help you identify tricky exam phrasing before you ever sit for the real certification test. Ensure you take advantage of the practice test included with this lesson to actively lock in this complex sequence. Maintain this fantastic energy as we naturally transition into our next section, where we will explore advanced data mapping, filtering, and transformation techniques. Welcome to the fourth section of our Oracle GoldenGate 23ai certification course, where we elevate your skills by exploring data mapping, filtering, and transformation techniques. In this lesson, you will learn how to change, filter, and manipulate your data while it is actively flowing through the replication pipeline. This topic is incredibly important because real-world companies rarely have identical source and target databases, meaning you must act as a data translator to bridge those gaps. Prepare to unlock the true power of GoldenGate as a data integration engine, creating excitement as you move beyond simple copying into intelligent data routing. Let us dive into these transformation techniques and prepare you for some of the most practical questions on the certification exam. Until now, we have assumed that you want to replicate every single row of data exactly as it appears in the source database. However, in enterprise environments, you often need to restrict which records are sent across the network to save bandwidth and storage space. For example, your target analytical system might only need data for active customers, while ignoring inactive or deleted accounts. This process of selecting specific rows based on business rules is called filtering, and it is a core competency you must master. Understanding why and when to filter data is critical for designing efficient replication pipelines that only move valuable information. The simplest way to filter rows in Oracle GoldenGate is by using a where clause inside your parameter files, just like a standard database query. You can add a where clause to your table or map statements to evaluate specific column values. If you write where status equals active, GoldenGate will instantly ignore any row where the status column says anything else. This keeps unwanted data from ever entering your trail files, making your entire replication process significantly faster and more lightweight. The exam will definitely test your ability to write basic where clauses to filter out unnecessary transactions. While the where clause is excellent for simple comparisons, it has limitations when dealing with highly complex mathematical or logical conditions. For more advanced row filtering, GoldenGate provides the filter clause, which utilizes built-in evaluation functions. With the filter clause, You can extract a specific year from a date column and compare it against a mathematical formula before deciding to replicate the row. You should expect exam questions asking you to choose between the where clause and the filter clause. So remember that where is for simple checks, and filter is for complex computational logic. Once you have filtered the correct rows, you often need to address the fact that your source and target databases have completely different designs. Your source system might store employee records in a table named staff, while your target system expects them in a table named workers. To solve this, you use data mapping, which is the process of explicitly linking a source table to a completely different target table. You configure this routing using the map statement inside the Replicat parameter file, ensuring the incoming data lands safely in its new home. Simply mapping the table names is rarely enough, because the columns inside those tables will likely have different names as well. Your source table might have a column named EMP_ID, but the target table expects a column named employee_number. To bridge this gap, you must use the COLMAP parameter, which tells the Replicat process exactly which source column matches which target column. Writing a COLMAP statement involves listing the target column first, followed by an equals sign, and then the source column name. Mastering the exact syntax of the COLMAP parameter is an absolute necessity for passing the certification exam. Writing out individual column mappings can become incredibly tedious if you have a table with 200 columns, especially if most of them actually share the exact same names. Thankfully, GoldenGate provides a brilliant shortcut keyword called USEDEFAULTS, which you place inside your COLMAP statement. When you type USEDEFAULTS, GoldenGate automatically maps any columns that have identical names, leaving you to manually type out only the few exceptions that are actually different. This keyword saves administrators countless hours of typing and prevents frustrating typographical errors, making it a favorite trick tested by exam writers. Beyond simply renaming columns, you will frequently need to change the actual data values themselves while they are traveling across the network. This is known as data transformation, and it involves applying specialized GoldenGate functions to alter the payload before it is written to the target database. For example, you might need to force all customer email addresses into lowercase letters, or strip out dashes from phone numbers. Transforming data on the fly prevents you from having to write complex cleanup scripts after the data has already landed in the target system. To perform these changes, you will use GoldenGate built-in string manipulation functions directly inside your COLMAP statements. One of the most common functions is strcat, which allows you to concatenate or merge multiple source columns into a single target column. If your source database has a first name column and a last name column, you can use strcat to instantly combine them into a single full name column on the target. Understanding how to use functions like strcat, strup for uppercase, and strsub for substituting text is vital for the exam. Another critical area of transformation deals with dates and timestamps, which are notoriously difficult to synchronize across different database brands. An Oracle database might store a date in one specific format, while a target Microsoft SQL Server database demands a completely different layout. You can use GoldenGate date functions to intercept the source timestamp, reformat it into a universal structure, and deliver it perfectly formatted for the target engine. Knowing that GoldenGate has powerful built-in date transformation tools will help you answer complex heterogeneous replication questions. You can also perform mathematical transformations using arithmetic functions built into the replication engine. By utilizing the compute function, you can multiply a product price by a tax rate, generating a final total cost column on the target database that never even existed on the source. This ability to generate new data points on the fly turns GoldenGate from a simple replication tool into an active data enrichment pipeline. The certification exam expects you to know that GoldenGate can mathematically calculate new column values without requiring external software. Sometimes, the data you need for transformation does not exist in the source trail file, requiring you to look it up from an outside table. For this, you use an incredibly powerful feature called SQLEXEC, which allows the GoldenGate process to pause and run a custom database query. For example, if your trail file contains a small country code, SQLEXEC can instantly query a reference table to find the full country name and insert that full name into your target database. SQLEXEC is heavily tested on the exam because it enables highly complex data enrichment during replication. While SQLEXEC is incredibly powerful, it can severely damage your replication performance if it is not configured carefully. Running a brand new database query for every single row being replicated will cause massive lag, dragging your high-speed pipeline to a crawl. To prevent this, you must always configure SQLEXEC to cache its results in memory, so it only queries the database once for each unique value. The exam places a huge emphasis on performance tuning, so always remember that caching SQLEXEC results is the mandatory best practice for real-world deployments. In highly secure environments, auditors often want to know exactly when a database change happened and which network user made the change. GoldenGate can capture this hidden transaction metadata using a feature called environment tokens. You can map these special tokens to columns in your target database, effectively building an automated audit trail that records the user ID, timestamp, and transaction sequence number of every single update. Understanding how to extract environmental variables using tokens is a sophisticated skill that distinguishes an expert GoldenGate administrator from a beginner when moving data between entirely different geographical regions. You will likely encounter character set conversion challenges. A database in Japan might use a specialized Asian character set, while a database in Europe uses a standard Western character set. GoldenGate is intelligent enough to automatically translate these character sets during the delivery phase, ensuring that special symbols and foreign alphabets are not corrupted into unreadable question marks. The exam will expect you to recognize that character set translation happens seamlessly if your target database environments are configured correctly. With all these complex transformations happening simultaneously, there is always a chance that a specific record will fail to apply due to a data error. Instead of allowing the Replicat process to crash and stop all data flow, you must configure error handling using the REPERROR parameter. The REPEROR parameter tells GoldenGate exactly what to do when it encounters an error, such as ignoring the specific bad record and continuing to process the rest of the healthy data. Mastering the REPEROR parameter ensures your replication pipeline remains highly available even when bad data slips through. When you tell REPEROR to ignore a failing record, you must not let the dropped data simply disappear into thin air. You must capture those failed transactions by configuring a discard file, which is a simple text document where GoldenGate writes down any rejected records and the specific error message. Database administrators rely heavily on discard files to investigate exactly why a transformation failed, allowing them to fix the data and manually reapply it later. Knowing how to configure and read a discard file is absolutely essential for real-world troubleshooting and certification success. A common architectural question you will face is deciding exactly where these transformations should take place. Should you perform the complex filtering and mapping on the source server using the extract, or on the target server using the Replicat? The universal best practice is to perform heavy transformations on the target Replicat process, which protects your critical source production database from unnecessary processing overhead. The exam frequently tests this architectural concept, so remember to capture raw data quickly at the source and perform the heavy manipulations safely at the target. By combining these mapping, filtering, and transformation tools, you can satisfy almost any complex business requirement your company throws at you. You can filter out sensitive credit card numbers, map older schemas to modern data warehouses, calculate new analytical metrics, and build comprehensive audit trails all in real time. These techniques transform Oracle GoldenGate from a simple backup tool into an enterprise data integration hub. Reviewing these specific parameter names and functions will give you a massive advantage when facing scenario-based questions on the certification exam. Congratulations on successfully completing Section 4 and mastering the complex art of data mapping, filtering, and transformation. I strongly encourage you to complete the attached practice test right now to apply these specific parameters and functions to realistic scenarios. Working through practice questions improves your long-term retention and guarantees your readiness by forcing you to identify correct syntax under pressure. Because the practice test is included with this lesson, you can immediately transition into active learning and solidify these crucial skills. Keep up the phenomenal work, and I will naturally transition you into our next section, where we will tackle advanced features, artificial intelligence integration, and high availability. Welcome back to the fifth section of our Oracle GoldenGate 23ai certification course, where we explore the bleeding-edge advanced features, artificial intelligence integrations, and high availability architectures that make this release truly revolutionary. In this lesson, you will learn how to replicate complex AI vector embeddings in real time and how to design robust active-active database environments that never experience downtime. This is incredibly important because modern enterprises are rapidly adopting generative AI and global cloud deployments, and they need engineers who can synchronize these massive distributed workloads. Prepare to have your mind blown as we bridge the gap between traditional database replication and the future of artificial intelligence. Let us dive into the future and master the advanced capabilities that define the 23ai platform. the absolute defining feature of Oracle GoldenGate 23i, and a major focus of the certification exam, is its native support for artificial intelligence vector embeddings. A vector embedding is a complex mathematical representation of unstructured data, such as a large text document, an image, or a video file. When you ask a generative AI chatbot a question, it searches through these mathematical vectors to find the most contextually relevant information. GoldenGate 23i is the first replication technology capable of seamlessly reading these massive vector data types directly from the database transaction logs and transmitting them across the network in real time. This real-time vector replication is critical for a modern AI architectural pattern known as retrieval-augmented generation, commonly referred to as RAG. RAG pipelines require absolute access to the freshest possible business data to prevent the artificial intelligence from hallucinating or providing outdated answers. By using GoldenGate to stream database changes into a centralized vector hub, you guarantee that your AI models are constantly querying live data, not stale nightly snapshots. The exam will test your understanding of how GoldenGate powers these RAG pipelines by keeping the vector store perfectly synchronized with your transactional systems. Another groundbreaking capability you must understand is zero-downtime vector migration. Many companies are actively trying to move their existing on-premises AI vector databases into the cloud, but they cannot afford to shut down their customer-facing AI applications during the massive data transfer. GoldenGate 23i solves this by allowing you to migrate millions of vector records into Oracle Cloud infrastructure without any service interruption. It buffers the incoming queries and updates during the move, ensuring a completely seamless transition between the old environment and the new cloud environment. You should also be aware that GoldenGate 23i provides heterogeneous vector replication, meaning it is not strictly limited to just Oracle databases. The software can safely capture and deliver vector data types for open-source platforms as well, including the highly popular PG vector extension used in PostgreSQL databases. This cross-platform capability allows enterprises to build massive, multi-cloud vector hubs where data from various different database brands is consolidated into one unified AI search engine. Expect exam questions focusing on this heterogeneous flexibility, as Oracle heavily promotes its ability to integrate with third-party vector stores. Moving beyond artificial intelligence, GoldenGate 23i introduces a completely modernized approach to event-driven architectures with its new data streams functionality. Instead of just writing data to a target database, Data Streams allows GoldenGate to publish real-time database events directly to a web-based messaging topic using the Async API standard. This means modern web applications, microservices, and mobile apps can securely subscribe to GoldenGate and receive instant push notifications the moment a database row is modified. Understanding the publish and subscribe nature of data streams is crucial for modern developer-focused exam scenarios. With these massive distributed capabilities, the physical location of your databases becomes incredibly important. Which brings us to the topic of high availability architectures. High availability simply means designing your environment so that if one server physically burns down, the business continues operating without any noticeable interruption. GoldenGate achieves this by keeping a secondary standby database perfectly synchronized with the primary production database. ready to take over in a matter of seconds. Knowing the difference between local high availability and geographical disaster recovery is a fundamental architectural concept on the certification test. The most complex and highly tested high availability design is the active-active or bidirectional replication architecture. In an active-active setup, you have two completely separate production databases, perhaps one in New York and one in London, and both are actively accepting user reads and writes at the exact same time. GoldenGate continuously captures changes from New York and sends them to London, while simultaneously capturing changes from London and sending them to New York. This ensures global users always experience lightning-fast local performance. But it introduces massive technical challenges that you must know how to solve. The biggest challenge in any active-active architecture is an endless replication loop. If New York sends an update to London, GoldenGate in London might mistakenly see that incoming update as a new local change and send it right back to New York, bouncing the data back and forth forever. To prevent this infinite loop, you must configure the extract process to explicitly ignore any transactions that were applied by a GoldenGate Replicat user. The exam will definitely ask you how to prevent data looping in bidirectional setups. So remember to filter out the Replicat user account on both sides. The second major challenge in an active-active setup is handling data conflicts, which occur when two users modify the exact same row at the exact same time. Imagine a user in New York updates a bank account balance, while a user in London updates that same bank account a split second later. By the time the data travels across the ocean, the two databases will have completely different balance amounts, leading to a massive data integrity failure. You must design your application carefully to minimize these geographical conflicts, perhaps by routing all European users to the London database and American users to the New York database. Even with careful geographical routing, conflicts are eventually going to happen, which is why Oracle GoldenGate features automatic conflict detection and resolution, known as Auto CDR. When a conflict occurs, the Replicat process pauses and looks at a set of predefined mathematical rules to decide which database update should win and which should be discarded. The most common rule is to look at the invisible timestamp of the transaction and simply allow the latest timestamp to overwrite the older data. The 23i exam places a massive emphasis on Auto CDR, as it is the absolute mandatory safety net for any active-active deployment. To detect these conflicts accurately, GoldenGate relies on a database feature called supplemental logging, which we discussed during the installation section. For Auto CDR to work, the database must log the before image of the data, which is exactly what the row looked like before the user changed it. When the Replicat arrives at the target database, it compares this before image to the current row, and if they do not match, it instantly knows a conflict has occurred. You must remember that before image logging is the mechanical trigger that actually alerts GoldenGate to a data collision. Setting up Auto CDR in an Oracle Database 23i environment is remarkably simple because it is handled entirely by a built-in database package called dbms_GoldenGate_Admiral. You do not have to write hundreds of lines of complex parameter code. You simply log into the database as an administrator and execute the add_auto_CDR procedure against your table. The database engine automatically creates the necessary invisible timestamp columns and prepares the internal logic required to negotiate the conflicts. You will absolutely be tested on your knowledge of the dbms_GoldenGate_ADM package and its role in modern conflict resolution. What happens if a user in New York updates a row, but a user in London completely deletes that exact same row? To solve this specific delete conflict, Auto CDR utilizes a hidden mechanism known as a tombstone table. Instead of instantly wiping the deleted row from the hard drive, the database temporarily moves it to a tombstone table so the Replicat process can still evaluate the timestamp and decide if the deletion was legitimate. Understanding that tombstone tables act as temporary graveyards for deleted records is a highly advanced concept that frequently appears on the exam. While Auto CDR is the modern standard for Oracle-to-Oracle environments, it does not work for heterogeneous environments involving third-party databases like Microsoft SQL Server. If you are running an active setup with a non-Oracle database, you must configure manual conflict resolution using the COMPARECOLS and RESOLVECONFLICTS parameters. These manual parameters require you to explicitly write out the exact before-image comparison logic and the mathematical resolution rules inside your Replicat parameter file. The exam expects you to know that Auto CDR is strictly for Oracle databases, while COMPARECOLS is the manual fallback for heterogeneous systems. Another brilliant high-availability use case for GoldenGate is performing zero-downtime database upgrades. If you want to upgrade your legacy Oracle 19c database to the new Oracle 23i release, you can use GoldenGate to keep the old and new systems synchronized while you test the new application. Once you are fully confident the 23i database is working perfectly, you simply redirect your user traffic to the new server and turn off the old one, achieving a major version upgrade with 0 seconds of application downtime. Upgrades and migrations are heavily tested scenarios because they are the #1 reason companies initially purchase GoldenGate. To ensure these mission-critical high-availability architectures survive server failures, GoldenGate microservices can be integrated directly with Oracle Clusterware. Oracle Clusterware is a standalone infrastructure program that constantly monitors your physical servers for sudden power outages or hardware crashes. If the primary server suddenly dies, Clusterware will automatically move the GoldenGate Service Manager and its network IP address to a surviving backup server, restarting the replication processes automatically. Knowing that GoldenGate integrates natively with Oracle Clusterware for automated failover is a key component of enterprise architecture planning. When deploying in the cloud, you can utilize the fully managed Oracle Cloud Infrastructure, or OCI, GoldenGate service instead of installing the software manually. OCI GoldenGate is a cloud-native platform where Oracle handles all the patching, high-availability routing, and infrastructure scaling behind the scenes automatically. You simply log into a web browser, select your source and target databases, and the cloud provisions a highly available 23i microservices environment in a matter of minutes. The certification exam covers both on-premises installation and this managed OCI cloud service. So you must understand the benefits of both deployment models. By combining these advanced features, you elevate GoldenGate from a simple data mover into a highly resilient, globally distributed data fabric. You can seamlessly synchronize complex AI vector embeddings, publish real-time events to web applications, and protect your enterprise from catastrophic data center failures using active-active architectures. Mastering conflict resolution and zero-downtime migrations will make you an invaluable asset to any cloud engineering team and guarantee your success on the most difficult portion of the exam. Review these advanced architectural concepts carefully, as they separate the absolute beginners from the true GoldenGate masters. Congratulations on conquering the fifth section and mastering the absolute cutting-edge features of Oracle GoldenGate 23i, including AI integration and high availability. I strongly encourage you to tackle the attached practice test right now to lock in these complex active-active scenarios and conflict resolution parameters. Practice questions are proven to improve your analytical thinking and will train your brain to quickly identify the correct architectural solutions under the pressure of the real exam. Since the practice test is included with this lesson, take advantage of this active learning opportunity to validate your new knowledge. Keep this incredible momentum going as we naturally transition into our final section, where we will master monitoring, security, and advanced troubleshooting techniques. Welcome to the final section of our Oracle GoldenGate 23i preparation course, where we focus on keeping your replication environment secure, healthy, and highly performant through advanced monitoring, tuning, and troubleshooting. In this lesson, you will learn how to protect your microservices using enterprise-grade security, pinpoint the exact root cause of data lag, and resolve common replication errors that pop up during operations. This topic is incredibly important because once a system goes live, your primary job is to ensure it runs without interruption, which is exactly why the certification exam contains so many troubleshooting and performance scenarios. Get excited because this is where you develop the elite diagnostic skills that true production experts possess, giving you the final boost of confidence you need to pass your exam. Let us dive right into these critical operational techniques and finish our training strong. To keep a complex replication environment running smoothly, you must have constant visibility into its operations, which is the main job of the performance metrics server. The performance metrics server continuously gathers critical performance data, such as the number of operations processed per second, the current data lag, and memory consumption for every running process. It exposes this data through a beautiful web dashboard and standard REST API endpoints, allowing you to easily feed these metrics into external corporate monitoring tools like Prometheus or Grafana. The certification exam expects you to know that the performance metrics server is your primary diagnostic hub for analyzing system health when monitoring your replication processes. The single most important metric you will track on a daily basis is lag, which measures the delay in data delivery. There are actually two distinct types of lag you must understand for the exam, known as capture lag and delivery lag. Capture lag is the time difference between when a transaction is committed in the source database and when the extract process actually reads it from the log files. Delivery lag is the time difference between when the Replicat process reads a transaction from the trail file and when it finally writes it into the target database. Distinguishing between capture lag and delivery lag is the secret to quickly diagnosing where a performance bottleneck is located along your replication pipeline. If you notice that your capture lag is extremely high but your delivery lag is 0, it means the bottleneck is on the source side. Likely because the extract process cannot read the transaction logs fast enough. Conversely, if your capture lag is low but your delivery lag is skyrocketing, it means the extract is doing its job perfectly, but the Replicat is struggling to write data into the target database. To fix high delivery lag caused by a slow Replicat process, you must know how to apply specific performance tuning techniques to accelerate data processing. The most common cause of a slow Replicat is a lack of proper indexes on your target database tables. When the Replicat tries to update a row, it must first search the entire table to find that row. And if there is no index, it will perform a slow full table scan for every single transaction. Ensuring that your target tables have matching primary keys or unique indexes is the #1 performance tuning recommendation for GoldenGate environments. If your indexes are perfect, but the Replicat still cannot keep up with a massive workload, you should tune the process by adjusting its memory buffers and commit intervals. By default, the Replicat commits every single transaction individually, which causes a significant amount of disk writing overhead on the target database. You can use the BATCHSQL parameter inside the Replicat parameter file to instruct GoldenGate to group hundreds of similar insert or update statements into a single memory buffer and apply them all at once. Utilizing BATCHSQL is a heavily tested exam topic because it provides a massive speed boost for high-volume delivery operations. Security is just as critical as performance tuning, and you must know how to secure all communications within your microservices architecture using modern encryption. GoldenGate 23i relies extensively on secure sockets layer certificates to verify the identity of servers and encrypt data moving across the network. When you configure a secure deployment, every single piece of data traveling inside a trail file or between microservices is completely encrypted using advanced encryption standard algorithms. The exam will expect you to understand how digital certificates prevent malicious network eavesdropping and ensure absolute data privacy. Beyond network encryption, you must also secure access to the web dashboards by setting up a robust user authentication and authorization system. GoldenGate 23i allows you to integrate its security framework directly with enterprise identity providers using lightweight directory access protocol or security assertion markup language. This means you do not have to manage separate passwords for GoldenGate. Instead, administrators can log in using their standard corporate network accounts. You must know that role-based access control allows you to grant read-only viewing rights to operators while restricting full configuration rights to senior engineers. Even in a perfectly tuned and highly secure environment, you will eventually encounter operational errors that cause an extract or Replicat process to suddenly abend. Abend is a technical term used in GoldenGate that stands for abnormal ending, meaning a process has crashed due to an unhandled error. When a process abends, The very first tool you should use to investigate the failure is the admin client or the web dashboard to check the process status. The exam will present realistic scenarios where a process has abandoned, and you must know the exact diagnostic steps to discover what went wrong, to find the specific error code that caused an abnormal ending. You must open and inspect the report file associated with the crashed process. Every single extract and Replicat process automatically generates a dedicated report file on the server file system every time it starts up. This report file acts as a comprehensive diary, recording the exact parameter rules that were loaded, the database connection status, and the precise database error message that triggered the crash. Knowing that the process report file contains the official diagnostic log is a fundamental rule for troubleshooting certification questions. In addition to individual process report files, GoldenGate maintains a global master log file for the entire server called the GGSERR log file. The GGSERR log file acts as a centralized historical timeline, recording major system events such as the starting and stopping of microservices, disk space alerts, and network connection drops. If your service manager completely stops working or a microservice refuses to launch, you will not find the answer in a process report file. You must look inside the GGSERR log file instead. Memorizing the difference between a process report file and the global GGSERR log file is highly relevant for exam success. One of the most common database errors that causes a Replicat process to abend is an integrity constraint violation, such as an Aura 00001 unique constraint error. This error occurs when the Replicat attempts to insert a row with a primary key that already exists inside the target database table. Another common error is a missing row violation, which happens when the Replicat tries to update or delete a record that does not actually exist on the target side. These errors usually indicate that your initial load was performed incorrectly or an unauthorized user manually modified data on the target system. When these data integrity errors occur, you can temporarily bypass the crash by utilizing the discard file that we learned how to configure in the transformation section. By reading the discard file, you can inspect the exact database columns and values that caused the violation, allowing you to understand why the source and target databases are out of sync. Once you identify the problematic records in the discard file, you can manually adjust the target database data to match the source, resolving the underlying conflict and restoring smooth data flow. If you encounter an error that is not related to data values but is instead caused by a network disruption, you should use the automated restart features built into the Service Manager. Inside the web dashboard, you can configure critical processes with an automatic restart policy, telling the Service Manager to try launching a failed process multiple times before giving up. This prevents an administrator from having to wake up in the middle of the night to fix a temporary network flicker, as the system will heal itself automatically once the network connection returns. A highly advanced troubleshooting scenario you might face on the exam involves a situation where an extract process is running perfectly but is not writing any data to the trail files. This strange behavior usually occurs because a user has started a massive transaction on the source database, but has forgot to commit or roll back the changes. Because GoldenGate only replicates committed data to ensure accuracy, the extract process must keep buffering those changes in memory, waiting indefinitely for the commit signal. You can use the info extract command with the showtrans option to instantly locate these long-running uncommitted transactions. To manage these long-running uncommitted transactions before they exhaust your server memory, you should configure the warnlongtrans parameter inside your extract parameter file. This parameter allows you to specify a time limit, such as 24 hours, after which GoldenGate will automatically write a warning message to the GGSERR log file identifying the offending database user. This alerts the database administrators to find the careless user and terminate their idle session, freeing up system resources and preventing a potential replication bottleneck. Expect exam questions focusing on how warnlongtrans protects system stability. Another critical file management task you must automate is the cleanup of old, processed trail files using the manager or deployment purging rules. If you do not configure an automated purge policy, your server hard drives will eventually fill up completely with historical trail files, causing the entire GoldenGate environment to crash. You should use the PURGEOLDEXTRACTS parameter to tell the system to safely delete any trail files that have already been completely read and applied by every downstream Replicat process. Automating trail file cleanup is a mandatory operational best practice for maintaining a healthy storage environment. When you need to perform maintenance on your servers, such as applying operating system patches or upgrading database software, you must know how to safely stop your replication processes. You should always stop the primary extract first to halt data capture. Allow the distribution server to finish flushing any remaining records across the network. And finally stop the target Replicat. Following this precise shutdown sequence prevents data from becoming corrupted and ensures that when the maintenance is complete, you can restart everything smoothly without losing your place. By mastering these comprehensive monitoring, performance tuning, security configuration, and troubleshooting techniques, you transform yourself into a complete Oracle GoldenGate 23ai professional. You now possess the deep technical insights required to design highly available architectures, optimize data flows for maximum throughput, protect corporate data with advanced encryption, and diagnose complex operational failures. This thorough understanding of the entire replication lifecycle is exactly what the Oracle 1Z0 to 948 certification exam is designed to test. And you are now fully equipped to conquer it. Congratulations on completing the final section of our comprehensive Oracle GoldenGate 23ai exam preparation course. I highly encourage you to complete the attached final practice test right now to validate your understanding of monitoring, security, and troubleshooting before taking your actual certification exam. Reviewing these practice questions will dramatically maximize your memory retention and ensure you are fully prepared for the specific scenario-based wording used by Oracle. Taking this final practice test included with this lesson is the ultimate active learning step to lock in your expertise and guarantee your exam readiness. Stay positive, trust your training, and prepare to celebrate your success as a newly certified Oracle GoldenGate 23ai professional.